Hello and welcome. I'm Pooja Thakur, Senior PM at Azure Boost. Many customers are scaling their applications on Azure, from global gaming platforms to massive financial services. But as they scale, they sometimes encounter unexpected performance bottlenecks, latency spikes, throttling, or DNS resolution failures. The root cause often isn't the application itself, but a mismatch between the workload and the underlying infrastructure settings or configurations or services. Today, we're going to pull back the curtain on the secret sauce of Azure's architecture. We'll discuss how a fundamental redesign of our infrastructure, combined with the right VM choices and configurations, can unlock massive performance gains for your workloads. Our goal is to equip you with the knowledge to build and run your applications on Azure with maximum efficiency, performance, and scale. Over the past few years, Azure's compute infrastructure has undergone significant enhancements with a project called Azure Boost. We have re-architected our servers while ensuring your production workloads continue running without interruption. So what is Azure Boost? It's a system that runs on a custom-designed hardware card that goes into every new server in the Azure fleet. This system offloads critical infrastructure tasks, like networking and storage processing, that traditionally run on the main CPU. By offloading these tasks to dedicated hardware, the server's CPU cores are fully available to run your application. This is what an Azure Boost hardware looks like. As you can see, it is a proprietary Microsoft technology, designed, secured, and manufactured specifically to work with Azure servers. This has profound implications. More resources for you. You get predictable performance because the host OS isn't competing with your VM for CPU cycles. Enhanced security. It provides a stronger isolation boundary between customer workloads and our infrastructure management. Breakthrough performance. It enables massive improvements in storage and networking throughput and latency. Every new Azure data center is built with Azure Boost hardware, and all the VM families presented today are powered by Azure Boost. Now let's look at how you can use Azure Boost to unlock maximum gains. Azure Boost has fundamentally changed what's possible for networking in the cloud. We've achieved several key milestones. Massive throughput. We now support up to 400 gigs throughput of network bandwidth on our largest VMs. Unprecedented reliability. The Boost hardware features dual top-of-rack connectivity. This active-active setup means that if a physical switch port or cable fails, your VM's connectivity is maintained seamlessly, often with no noticeable interruption. And sub-second maintenance. For latency-sensitive workloads like gaming or high-frequency trading, infrastructure maintenance can be disruptive. With Azure Boost, we can perform network maintenance like driver updates with sub-second impact. To bring this power to your specific workloads, you can use our latest network-optimized VMs. You will see them labeled with a lowercase n, like DLNSV6 or DNSV6 or ENSV6. These VMs offer up to 400,000 connections per second, making them perfect for network virtual applications, firewalls, and real-time analytics. To harness this power, follow these key best practices. Choose a modern VM series to ensure you're running on Azure Boost infrastructure. Use a modern operating system that supports accelerated networking with the Microsoft Azure Network Adapter or MANA driver. This bypasses the virtual switch and gives your VM direct hardware access for a dramatic reduction in latency and jitter. Benchmark correctly. Don't use ICMP ping to measure latency. It's often deprioritized in the network. Instead, use tools like SOCPerf or Latte that measure latency for actual TCP or UDP flows. Understand connections as a resource. Each network connection consumes state on our platform. For connection-heavy workloads like NVAs, use the new network-optimized VMs to avoid hitting flow limits. Just like with networking, Azure Boost offloads storage processing directly to hardware, delivering best-in-class performance. For remote storage using Azure Managed Disks, we now deliver up to 20 gigabytes per second of throughput and up to 1 million IOPS. For local storage, we've introduced the Azure Boost SSD. This helps us deliver up to 36 gigabytes per second of throughput and an impressive 6.6 million IOPS. So how can you get the best storage performance? Choose the right managed disks. Azure offers several high-performance managed disk options. Premium SSD V1 is well suited for read-heavy workloads because it supports host caching. Premium SSD V2 delivers very low latency and high throughput, making it ideal for write-heavy or latency-sensitive applications. Ultra disks provide the highest performance overall with extremely low latency, very high IOPS and throughput, and the ability to adjust performance settings without restarting VMs, albeit at a higher cost. Ephemeral OS disks are stored on the VM's local SSD and are best for stateless workloads that need extremely fast boot and reset times. Keep in mind that throttling occurs on a per disk basis and a per VM basis. Ensure your chosen VM provides the IOPS and throughput headroom that your application needs. Don't assume that the defaults will work for every high-performance scenario. So how do you choose the right VM for your use case? Azure Boost provides the foundation, but its capabilities are exposed through our VM families. Our VMs are based on several CPU architectures, each optimized for different scenarios. And you can choose based on the performance you require and your budget. And of course, doing actual testing will always give you a better idea of what works for you. Azure's Cobalt 100 VMs. These VMs offer the best integer performance per vCPU per dollar. A vCPU on Cobalt is a dedicated single-threaded core with dedicated caches. They are an excellent choice for scale-out cloud-native Linux workloads. AMD-based VMs. These VMs deliver the best x86 integer performance per dollar. The FA series with symmetric multi-threading disabled is particularly great for workloads sensitive to single-threaded performance. Intel-based VMs. These VMs provide the largest VM sizes, scaling up to 192 vCPUs and nearly 2 terabytes of memory. Their large caches benefit data-intensive workloads, and the support for advanced matrix extensions accelerates AI workloads. All of these VMs are available in multiple regions. Whether you're running business-critical or cloud-native or AI workloads, Azure has a portfolio of virtual machines to meet your requirements. We have a list of VMs here that are well-suited to run general-purpose, compute, storage, or network-intensive scenarios. And to simplify acquiring capacity, especially at scale, you can use the Azure Compute Fleet. You can specify a list of acceptable VM types or define attributes like vCPU and memory requirements. Azure Compute Fleet then automatically provisions resources from available capacity, also intelligently blending spot and on-demand instances to optimize costs. Given this broad range of VM options, let's look at VM provisioning advantages with Azure Boost. Azure Boost unlocks faster, more predictable provisioning across multiple workload scenarios. Moreover, if you're deploying large, performance-sensitive workloads or managing at-scale infrastructure, Azure Boost significantly enhances the provisioning experience. Azure Boost benefits multiple scenarios. For example, services that scale VMs in and out based on load. Faster VM spin-up time allows you to respond to demand spikes more quickly. Reduced overhead on host allows more VMs to be deployed per host without hitting CPU, network, or storage bottlenecks. Big data analytics, training ML models, or rendering workloads that provision hundreds or thousands of VMs at once. High remote storage throughput and IOPS allow faster disk image copying and VM setup. Dedicated hardware handles system tasks, preventing saturation of host resources during large deployments. Scientific modeling, financial risk analysis, or other compute-bound or I/O-bound workloads also benefit from Azure Boost. Boost SSD delivers higher throughput for local disks. Large VM sizes benefit more from stable host performance due to offloaded background services. Azure Boost can also help with environments where VMs are frequently created and tested as part of development pipelines. Reduced provisioning and boot times allow developers to test code faster. Lower latency is seen for ephemeral VM setups used in CI pipelines. Disaster recovery and region failover. Rehydrating infrastructure from backups or images in the event of a regional outage or system failure. Users can see faster provisioning of large number of VMs in a short window. High disk throughput speeds up image deployment and data restore. Azure dedicated host deployments. Customers using ADH for isolation, licensing, or regulatory needs benefit from Azure Boost. Boost allows higher VM density or larger VMs per host by reducing system overhead. Provisioning new VMs on dedicated hosts becomes faster and more efficient. So how do you unlock all these advantages with VM provisioning? For parallel or scale-out provisioning, you can stagger provisioning of many VMs rather than launching all at once to avoid hitting throttling on shared resources like storage and network. You can monitor resource utilization when doing scale-outs to ensure host isn't saturated in disk I/O or network. For networking or NIC setup, use latest supported OS and drivers so the VMs and host can use network enhancements that Boost supplies. Where possible, use high bandwidth network configurations like accelerated networking to reduce networking overhead in provisioning. When it comes to cost density optimization, for Azure dedicated hosts, use Boost to increase VM density or scale up existing ones. Consolidate workloads into fewer hosts when possible, given the performance headroom Boost provides. With Azure Region or Availability Zone, provision in regions where Boost is available. Consider using availability zones to improve resiliency and reduce blast radius for host failures or maintenance. The key takeaway is this. Azure has fundamentally enhanced its IaaS platform with Azure Boost to deliver best-in-class performance, security, and reliability. To unlock this potential for your applications, the path is clear. Modernize your foundation. Choose from our latest VM series to build on the Azure Boost hardware. Use a modern OS. Select a recent supported OS image. This is essential for achieving peak performance. Match the VM to the workload. Select the right CPU architecture, Cobalt, AMD, or Intel, and the right VM family, whether it's general purpose, network, or compute optimized, to best suit your application's needs. So by aligning your application with these modern infrastructure capabilities, you can push the boundaries of scale and deliver a faster, more reliable experience for your users. Thank you for your valuable time. We hope you've gained some practical insights into leveraging Boost for your applications.